You are listening to Chibalama Rogers, a teacher of geography, and I welcome you to this platform. And in this video, of course, I have a simple question for you, and it is all about statistics. It is a question, of course, that is portraying the aspect of statistics, and I'm sure by the end of this video, you will be in position to handle any statistical number concerning climate. Now, the reason as to why I've brought in this item is that you may find that many students confuse what we call a bar graph. You know, we normally have a number of statistical diagrams that are handled in geography, but there is some bit of confusion. Students tend to confuse different statistical diagrams. So before we move on to this, let me make this clear. We have what we call a bar graph. We have a line graph. We have the one that is combined, a combined bar and line. Then you also have a grouped bar graph. Basically, for the case of graphs, these ones are so common. However, it is important to note that when it comes to a bar graph, here you have to leave space in between the bars. It is so important. So meaning that under a bar graph, each bar should be independent, standing alone. So right from the start, as you are drawing the first vertical axis, make sure you leave space. Then you start drawing the first bar, you leave space. The second one, you leave space. The third one, leave space, up to the last one. Then after drawing the last bar, again you leave space and you draw the second vertical axis. Let me hope this one is clear. Then for the case of a line graph, of course, after analyzing your information, make sure for the case of a line graph, as you are plotting, you plot in between the years. Let me say amongst the information you have, you've been given years. In between the years, that is where you follow up and find where the point can be placed. Then after making all those plots, what do? You join the points using a ruler. You join the points using a ruler. And the line should be hanging in space. That is the case of a line graph. It should be hanging in space and it shouldn't be attached to any of the axes. Then for the case of a combined bar and line graph, now this one is a combination of bars and a curve, which we call a line. This will be our focus for today, but I wanted to make it clear there is a difference between a combined bar graph. There is a difference between a combined bar and line graph and a line graph as well as a bar graph. The criteria for drawing them is different. Let me hope I'm clear there. So in this video, we shall be focusing on a combined bar and line graph. However, when you look at the last one, before we move to the combined one, you may find that a grouped bar graph, here you may be given information that is a little bit complex, whereby a lot of items are to be handled. So what you do, you space the bars just as you do it under the simple bar graph. However, under the grouped bar graph, you may find that the bars are spaced in groups. they are always spaced in groups. That is a grouped bar graph. So for this case, let's handle this. Then maybe later on some other time we shall be looking at a grouped bar graph as well as the simple bar graph. And we see how the two are different. So for the case of a combined bar and line graph, you may find that it can also be called a climatic graph. So the item is clear for those who are following up. It is very clear. Look at the question, and after reading the introducing statement of the question, let's analyze this table and see the kind of information that we have. Now, for the case of a combined bar line graph, in most cases, it is used for representing climatic statistics. It is purely used for representing climatic statistics. That is why when you are given information, we look at the key elements of weather. And one of them is temperature, which is measured in degrees Celsius. And the second one is rainfall, which is measured in millimeters. So the months are also there. So without wasting time, we shall be handling part by part. We have part A, part B, part C. So let's proceed. So to begin with part A, the information has been given. We have months, temperature, and rainfall. So, like I've told you, this one, it is also called a combined bar and line. So even if they bring a question and it is having draw a suitable climatic graph, just know it is a combination of bars and lines, in that bars are going to be representing rainfall, which is in millimeters. Then we shall represent temperature using what we call a line, or you can call it a curve. And this one is going to represent temperature, which is in degrees Celsius. So how are we going to do it here? First of all, you need a graph page or a graph paper. You will need a set, mathematical set. Of course, you will need a sharp pencil. Basically those. So when you have these, focus and analyze the information. After analyzing the information or the climatic statistics that has been given at your table, you begin. So suppose this is our graph page. This is the margin of the graph page. What do we do here? First, come up with the title for the information. So you can say a climatic graph, or you can say a combined bar line graph showing a climatic graph showing the climate of station F, showing the climate of station F. You underline it very well, and remember it should be in capital letters. Then after that, we move to our scale. And for this case, we shall be having two scales, the vertical scale and the horizontal scale. Now for this case, we shall be having two items to represent along the vertical axis. So vertical, under the vertical scale, remember I've told you we shall be having two kinds of scales. We shall have one for temperature and one for rainfall. But how are we going to do it? So this is our vertical axis. Remember, before drawing the vertical axis, you leave a space aside of 2 centimeters. So after drawing the vertical axis, you also draw the horizontal axis down here. After leaving a space of 2 centimeters for labeling. Then after that, let's try to look for the scale, the vertical scale for the two items. Along the vertical axis, you may find that we have a workspace of 20 centimeters. But remember, we have two items to represent. But these items, they have figures of different sizes. How? You may find that rainfall is having bigger values compared to temperature. So meaning that in whatever you are planning for, make sure that you reserve more space for rainfall than temperature, because temperature has lower values. And for this case, you may decide to say 5 centimeters for temperature and 15 centimeters for rainfall. That is very okay. So for this case, if you are a student who has planned like this, it means that you are planning for the bars to occupy a maximum of 5 centimeters. That is rainfall. And you are also planning for temperature to occupy 5 centimeters only, because the values are smaller. The values are smaller. So what next? We are planning for the two items, but let us begin with rainfall. Why? Because rainfall will be occupying the lower space. Then the temperature will be represented above, after indicating a freezing point somewhere there. How are we going to do it? We have a workspace of 15 centimeters for rainfall. So the deal is very simple. Look at the rainfall values, find out the highest value. The highest value will give you the way forward. So the highest value here, according to the information we have, is 208. If I'm not mistaken, it is 218. So you get 218. You divide it by your workspace, which is 15 centimeters. So for those who have calculators, you can punch in and see the answer. So it is something like 14.8, around there. So if you have such a figure, of course you cannot use it. It is not convenient, more so if you are working in the interest of time. So 14.8, what you do here, you don't use this very figure because it is not convenient. So simply move upwards or downwards so that your work may be simplified. How can we do it here? When you move upwards. Remember, make sure you choose a figure that is close to this. You choose a figure that is close to this and make sure that the figure is divisible by 5 so that as you are plotting, your work is simplified. So if you have 14.8, when you move upwards, you can either use 15 or 20. That is if you move upwards, 15 or 20. However, when you move downwards, you use 10. But for this case, 10 may not work out well. Let us use either 15 or 20 so that we can have enough space above to represent temperature using a line graph. So for this case, you come here and say 1 centimeter represents 15 millimeters of rainfall. That is for the case of rainfall. And when it comes to temperature, it is straightforward because in most cases, values of temperature, it is very rare to find a value of temperature exceeding 30. So in most cases, they range between, okay, it could be negatives for the case of these countries in Europe and other countries near the South and North Poles, it could be in negatives. But in the tropical countries, it can range between 20 to 30. That is the range, basically in Africa. It can also go below that. However, you may find that it is very hard for the temperature values to exceed 30. That is why I normally say that the scale for temperature seems to be automatic because you can just say 1 centimeter represents 5 degrees Celsius of temperature. You write the scale in full, then the horizontal scale, down we shall be representing months, and of course there are 12. There is no year that exceeds 13 months. There is no year that has more than 12 months. So horizontal, along the horizontal scale, you may find that we have 12 months, and of course we cannot use 2 centimeters for each month. We shall have to use 1 centimeter represents a month. That is how the scale for the climatic graph appears. Vertical scale, you have to plan for rainfall and temperature. Horizontal scale, you are planning for the months along the horizontal axis. So as you are starting to plot, remember down you start with rainfall. Every after a centimeter, 15. Here we have 30. Here we have 45. Here we have 60. Here we have 75, 90, 100 and 105. Then here we have 120, 135, 150, 165, 180, 195, 210, 225, 240, 255, then 270. We've moved beyond. So the highest value is 218. So I think we can stop at 22. 5, 2 to 5. That is where we can stop. Then after that, of course, on the next level, you will be drawing what we call the freezing point. That line that is separating rainfall from the temperature. So at that line, or at that point, you may find that it is where we indicate 0 degrees. Then above that, we shall have 5, 10, because for the case of temperature, it has a different scale where after a centimeter, you keep on adding 5 degrees Celsius, 15, 20, and finally 25. So we can stop there. Then down we shall be making divisions of 1 centimeter as we are indicating the months. This is January, February, March, April, May, June, July, August, September, October, November, and December. After indicating the last month, you automatically or you immediately draw the second vertical axis. What you do this side, you also do it this way. So here we shall have 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, until you complete all the values. So since you left enough space this side, you can indicate rainfall in millimeters. Same applies to this side, rainfall in millimeters. Up, of course, we have temperature, and it is in degrees Celsius. After labeling all the axes, what would be our next step? I think we can first handle rainfall. After drawing all the bars, then you can move to the plotting of the points and joining of those points to make a curve for temperature. So rainfall, of course, for this case, we are drawing bars that are close to each other. These bars won't be spaced. That is how such bars are different from the ones of a simple bar graph that we talked about earlier. For this case, we are going to leave the bars close to each other, no space, right from the beginning. So we are starting with January, and it has a value of 30 under rainfall, and it is clear. Make sure as you are drawing the bar, it is flat at the top. Let me try to use a ruler. Then the next one is 40, but 40 is not exactly there. What can we do? Let us try to determine the millimeters that are in between those spaces. So from 0 to 15, you may find that we have a space. This is 0, this is 15. So we have a space of 1 centimeter, but in between we have some divisions which are 5. 1, 2, 3, 4, 5. There are 5 subdivisions there. So meaning that we want to know what is contained in one small space in between there. So what we do, you get the 15, you divide it by 5 because we have 5 small boxes here. So you may find that each small box has a value of 3 millimeters. So meaning that for you to find out this 40, it means that every after a small box, just know you are counting something like 3 millimeters. Every after a box, 3. If this is 0, this is 3, 6, this is 9, this is 12, and 15. So for this case, we are starting from 30, and we want to find out where 40 is. So from 30, add the 1, 33, 36, 39, then 42. So meaning 40 is in between 39 and 42. So you try to follow up. Then the next one is 128. Here we have 120. Remember, we are adding on 3 plus a 1, 123, 126, 129, but we need 128. So it is slightly below 129. So you follow up, prolong this up to where that level is. So that is it for March. Then the next one is the one of April, and it is 195. That one is clear. You can see that you can simply follow up and get it. It's up there, 195. So this one is for April. Make sure the top of the bar is flat. Then we have 190. For you to get 190, it is in between 180 and 195. So meaning that we shall go back to this routine of adding 3, 3, 3, 3. So from 180, 183, 186, 192. So it is in between 100. This is 83, 86, 89, 92. So it is somewhere in between. Follow up and we join. So as you are seeing, the bars are close to each other. They are united. The bars are united. They are not independent. The next one is 40. So you follow up and find out where 40 is. I think this one has a similar value with this. So the bar of February and the one of June, they will be on the same level. So meaning that you can also follow up here. February is here, okay? So they should be on the same level. Then we have 54. So 54 is in between 45 and 60. Is in between 45 and 60. So you can see where we have 45. You add on 3. That is 48. When you add on 3, that is 51. When you add on 3, that is 54. So it is exactly there where you see the third line in between 45 and 60. So that is July. Then when you move to August, So you can see that at this point, we've exceeded the half of the year. And that means that we are a bit far away from this first vertical axis. So what can we do? Let us make good use of the second vertical axis. That is the use of this. Because when you are far away from this, you can easily use the one that is close to you. August, it has 98. So add on 3,390, 93, 96, 99. But we need 98. So close to 99. You come and follow it up. Then we have 130. 130. It is in between 120 and 135. So what can we do here? Still, we shall go back to our routine. 33, 123, 126, 129. Slightly above 129 is where we have 130. Somewhere there. Then we have 218. 218. This happens to be the highest value. So it is somewhere here where we have 210. Keep on adding 33, 213, 216, 219. So it is in between 16 and 19. Somewhere there. Then we have 145. 145 is in between 135 and 150. So you keep on adding 33, 1, 2. It is 135, 138, 141, and 144. Then 146. This is 135, 138, 141, 144, 146. Slightly above 144. That is where we have the figure. So you follow up and draw the second last bar. Finally, we have the last one at 37. It will be somewhere down here. 30. You keep on adding 33, 33, 36. Then above we shall have 39. But we need 37. So slightly above 36 is where we have 37. Then after that, so you can see that all the months have been represented. However, when you are shading, you shall have uniform shading. All the bars will be shaded uniformly. So if you decide to shade like this, make sure the shading is uniform. So if you've decided to shade in this format, make sure the shading is just uniform for all the bars. So uniformity is very important when it comes to this bar graph. So after that, rainfall has been handled, so we can move straight to temperature, where we shall have plotting of points, and then after plotting the points, we shall be joining them to make a curve. So we are starting with the month of January, just as we've done it for rainfall. However, when we are plotting, make sure you plot in between, in the middle of the month. Let me say this is January. It runs from here up to here, and in between you've indicated January. But remember, 1, 2, 3, 4, and 5. So it has a space of 5 smaller boxes. So you have a task of looking in between these points. So this is the first column, the second one, third, fourth, and the fifth. How are we going to determine the midpoint? Cancel the first one this side and the first one this side. You cancel the second one this side and the second one the other side. So the space that remains in between, it is where we shall put the point, following the level of the value along with the vertical axis. So meaning that the midpoint is normally the third column as you are coming from your left. The third column, it is the one that separates 2 aside and 2 this side. So meaning that for the case of January, we have a value of 20. Look at the midway of January. You move upwards. Go where 20 is. You put a plot there. That is the first one. Then we have 21. 21 for February. You move upwards. Remember, for this case, each small box has 1, 1, 1, 2, 3, 4, and 5. So here we shall have 20, 21. 21 is already there. You move upwards. Put 21 there. The next one is 22 in March. Move upwards. Put 22 there. Still, even in April, we shall have 22. Again, you move upwards. You indicate it there. We move back to 21. That is May. May, it has 21. You indicate it there. Then we move to June, where we have 20. Go back to 20. Then in July, still July has 20, the same level. Then August 21, move back up. Then September has 22, still up. October 22. Then November has 21, moves slightly below. And finally, December, it has 20. After making all of those points, allow me to clear this scale so that we can have a clear picture of this one. So after plotting all these points, so we assume that your second vertical axis has been prolonged up to that level, and the values are continuing to climb. 195, this is 210, and 225. So your freezing point is somewhere there. Let's have it with a straight line. This is 0. This is 5. This is 10. This is 15, 20, and then 25. We can stop there. Then this side we shall indicate temperature. It is in degrees Celsius. So after plotting all of these points, what we can do for this case, now I'm also bringing in another difference. And for this case, it is between the line that is drawn on this diagram and the line that is drawn independently. For a simple line graph, you join the points using a ruler. But for this case, this is a climatic graph. As we are joining these points, let us use a free hand. Make sure your hand is steady. It's better to use a sharp pencil. So join point by point, don't rush. Just be careful. After joining those points, you are free to join the curve to the vertical axis, which is not the case for a simple line graph. Now, for the case of a simple line graph, for it has to remain hanging in space. However, for this one, you can either leave it like this, or you can join the curve to the vertical axis, depending on your choice. So here you have freedom. The other side, for the simple line graph, join the points using a ruler and make sure the curve remains in space. So this is our freezing point. Don't forget to name it. This is the freezing point, and it is the point that separates rainfall values, or the representation of rainfall, from the one of temperature. So basically, this is how we come up with a combined bar and line graph, or you can call it a climatic graph showing the climate of station F. So that was part A. So from this graph here, you can easily identify the type of climate. Okay, so we've completed part A, and I'm sure we've handled it very well. But before we move on to the next part, down, don't forget to indicate months. So you can see that the graph is now well labeled. So I've told you from the graph, you can easily identify the type of climate. We are looking at the nature of the bars and how they are flowing throughout the year, and how the curve is changing or making variations from January to December. So for this case, the task is to identify the climatic type. Now, when you look at the nature of the bars, for you to identify the climatic type, you should be having some knowledge about the different types of climate at the back of your mind. Now, for this case, I'm seeing that we have two groups of bars. We have the first group of bars that are tall enough and they are exceeding the rest of the bars surrounding them. So this is an indicator that between the months of March and May, this area, or station F, experienced heavy rainfall, and this one can be called a rainfall peak. It's a rainfall peak, that period during which the area received the highest amount of rainfall. So you can see that the same or the similar situation happens between September and November. This is also another rainfall peak. So even during this period, the area receives extremely heavy rainfall. So at the back of your mind, ask yourself, which type of climate experiences two rainfall peaks? Then when you look at the temperature, you can see that the temperature values are not changing, or their variations is not much. So meaning that even the temperature range is small, which climatic type has small variations in temperature. So for this case, I'm sure this is what we call equatorial climate. Equatorial climate. Why? You give your reasons basing on what you have. It receives all it experiences. 2, rainfall peaks. That is 1. There are small temperature variations, or the temperature range is small basing on the curve. But if we add something of this kind, this couldn't be equatorial climate because the temperature is changing or variating at a very high rate. So for this case, it is equatorial climate because the curve is more or less flat. So part B is also answered. Then for the case of economic activities, here you look at the activities that take place in the equatorial regions. After identifying the climatic type, you can clearly come up with the economic activities. Failure to identify the climatic type, then even part C is a gone case. So we can have lumbering because of heavy rainfall. You cannot fail to talk about fishing. Water bodies are supplied by rainfall so that they can provide habitat for the fish and other aquatic life. Then you cannot fail to talk about agriculture, tourism. It is also there because of the forests, water bodies, and other drainage features. And they all happen just because of equatorial climate. Then you cannot forget about trade and commerce. Then transport and communication, more so when you talk about water transport, is also important. So there are a number of economic activities that can be carried out here. Talk about mining. For example, sand mining can also be common there. So those are some of the activities that can take place in the equatorial regions of East Africa as well as Africa. So from there, of course, there are some other aspects that are always raised when it comes to climatic graphs. And of course, let us wind up with these simple calculations that are so common under this part here. So the first one, we normally have the temperature range. It's normally called the annual temperature range. Now for this one, you get the highest temperature value and the lowest temperature value for you to get the answer. Then you also have annual temperature. So for this one, you simply get the sum of all monthly temperature values. You divide by 12. That is for the case of temperature. So the answer you get here will be in degrees Celsius. The same applies to this, degrees Celsius. Now there is also this one called mean annual rainfall. Now for this case, it is a little bit different. For the case of mean annual rainfall, you sum up all monthly rainfall values. You divide by 1 year. Here you divide by 12 months. So the answer you get here will be in millimeters. That is for the case of mean annual rainfall. Then the rainfall total, it is just a summation of all rainfall values throughout the year. So basically, that is what we call a climatic graph. So you will keep on raising more questions about it so that we can handle them So for those who have been following us and those who have just joined, I'm seeing some questions here. Let me respond to some of them as we wind up. Someone is asking, that is Pavin Marvin, but can all that fit on the graph paper? Okay, someone is asking, can all of this fit on one graph page? My dear, it is possible. Marvin, it is possible. It is all about planning for your work. You need proper planning because right from the beginning, I've been telling you that you are planning for something like 3 items to fit on the graph page. It looks hard, but when you plan for it very well, of course, it comes out well. More so when you look at the vertical axis, you may find that we shall have to represent 2 items there. But I've been telling you that since we normally have a workspace of 20 centimeters and rainfall has bigger values, so meaning that the greater portion of the space will be directed towards rainfall. So meaning that you can say 15 centimeters can be for rainfall and 5 centimeters can be for temperature, so that the space can be enough for you. So meaning that your bars, in whatever you're planning, they should not go beyond 15 centimeters. That is their limit. Beyond this is where you indicate your freezing point. So it is possible, Marvin. So someone has a good question here. If you have temperature below 0, if I have temperature below 0, what can I do? This is Musinguzi Philip. So if you have temperature below 0, what can you do? Now, if you have temperature below 0, and that means in your table you'll be having temperature values that are in negatives. So what you do for this case, let me try to summarize it here for the interest of time. You will be having maybe rainfall values up to that point. Let me say the highest value is 250. Then above, before your freezing point, you should be knowing that in the information you are given, you have negatives. That is if they are there. If you have negatives, then it means your freezing point will not be drawn immediately after the highest or immediately after the limit of rainfall. You will have to wait, because up here you may find that we shall put the freezing point in between. Why? Because in your values you have to cater for the negatives. So meaning that the freezing point for this case will be separating the negatives from the positives. The positives will be up, maintain the scale of 1 centimeter to represent 5. So here we shall have 0, 5, 10, 15, and 20. Then down, you will be indicating the negatives there. So it is because of the negatives that the freezing point will shift from this point up to a certain level, such that down you may cater for the negatives. This is -5, -10, -20, then -25. Then as you are plotting, you may see that your curve will be crossing from this side to this side, from this side to this side, indicating that there are variations, showing that temperatures have been changing from negatives as they are going back to positives, like that. So that is how you can do it. Then I'm seeing here Nakawuchi Fiona, what is amplitude? Amplitude, of course, amplitude, it is not so common here. However, you may find that amplitude, it is more or less the same as range. Amplitude, you look at the highest value and the lowest value. So someone has a question here. This is Ruth Nabada. You're asking, is it a mandate that we are supposed to start with rainfall? It is not a mandate, however, it is advisable, because when you start with rainfall down, you can clearly know the amount of space that has been left above so that you can indicate the freezing point and wind up with the temperature values or the curve, and you wind up with the curve. So that is it generally, and we've been handling what we call a climatic graph.